Hey everyone, today we're going to dive into a corner of JavaScript that trips up a lot of developers, handling streaming JSON. We're going to unpack this really cool technique known as the accumulator pattern and see how it elegantly solves a very common and pretty tricky problem.
So, it all starts with a situation that I'm sure many of us have been in. You're looking at some code that's supposed to process data as it comes in, chunk by chunk, and you see one line that just feels wrong, you know? A line that looks like it's throwing away perfectly good data.
And this is the exact question a junior developer, let's call him Timothy, asked his senior colleague, Margaret. He's looking at their code for handling ND-JSON, that format where every single line is its own JSON object, and he's totally convinced they're just dropping user data on the floor before it even gets a chance to be processed.
But what if that suspicious line of code wasn't a bug at all? What if it was actually the key to the whole thing? Well, in this explainer, we're going to solve Timothy's mystery and show you exactly why that one confusing line is the secret to reliably processing streams of data.
All right, let's get right into it by looking at the exact line of code that caused all this confusion in the first place. It's just one command, but on the surface, it seems to defy all logic.
There it is. Const last equals lines.pop. So after the code gets a chunk of data and splits it up into an array of lines, it immediately calls .pop. And for anyone who needs a refresher, .pop literally just removes the very last item from an array.
And that is the heart of the puzzle, right? The code takes this last item, which looks like a perfectly good user object, pulls it out of the lineup, only to stick it in a buffer. Why on earth would you do that? Isn't this exactly what Timothy was worried about? Aren't we just skipping a user?
Well, to understand why this isn't a bug, we need to look at this brilliant analogy that the senior engineer Margaret used. It really makes everything click. It's all about changing your perspective.
And this question just completely reframes the entire problem. We're not deleting data, we're just pausing. We're waiting for them to, finish their thought. But what exactly makes a piece of data complete when it's flying across a network? Okay, here's the core idea. Think of that new line character, the /n, as a period at the end of a sentence. You can't really be sure a sentence is over until you see that period, right? Well, in the world of ND-JSON, the new line does the exact same thing. It's the signal that says, okay, this JSON object is fully formed, it's ready.
And the reason this is so important is that networks, they just don't care about the structure of our data. When data streams, it gets broken up into chunks completely arbitrarily. A chunk can end anywhere, smack dab in the middle of a word, or in our case, in the middle of a JSON object. And if you try to parse that, your whole program will crash. So think about it. When we take an incoming chunk of data and split it by that new line character, everything before a new line is a complete sentence, a complete object. But what about the very last piece of that array? Well, that's whatever came after the final new line in that chunk. It doesn't have a period. It is, by definition, an incomplete fragment. And that brings us to the crucial point. Popping that last item off the array, it's not an act of deletion at all. It's actually the exact opposite. It's an act of preservation. It's carefully finding that potentially broken piece of data, that unfinished sentence, and it's setting it aside so our program doesn't blow up trying to parse it. It's basically a safety mechanism.
This slide really shows you the whole pattern in action. So watch this. A chunk of data comes in. See? It's got two complete objects and one partial one. We split it by the new line, and there's our little fragment hanging off the end. And here's the magic. .pop just plucks that fragment right out and saves it in a buffer. Now we can safely process the first two users. Then when the next chunk of data arrives, it gets tacked onto the fragment we saved, completing the object. See? It finally has its period and it's ready for the next cycle.
But this leads to one final, really clever question. If we're always saving the last piece for the next chunk, what happens at the very, very end of the stream?
This is the edge case that Timothy spotted. It's a fantastic question. Won't the very last user object get popped off and then just get stuck in the buffer forever since no more chunks are coming?
And the answer is a simple but absolutely crucial contract with the server that's sending the data. For this whole pattern to be foolproof, the server has to promise to send one final, trailing new line character at the absolute end of the entire stream. Because if that final new line is there, the very last chunk is going to look something like JSON ID 99/n. So when we split that by the new line character, our array will be /JSON ID 99/empty string, an empty string at the end. So the .pop method removes that last item, which is just a harmless empty string. The final user object gets processed perfectly, and nothing is left behind. Problem solved.
So what does the simple little pattern really give us? Let's zoom out and just summarize its real power, because its elegance is what makes it so incredibly robust.
You see, this pattern is so effective because it's highly deterministic. It doesn't need any complex, fragile logic like trying to count opening and closing brackets to figure out if a JSON object is complete. No way. It just relies on a super simple, reliable check. Does this string have a period, a new line, at the end of it? Yes or no? That's it. It's simple, it's fast, and it just works. Ultimately, the accumulator pattern transforms this messy, unpredictable streaming problem into a dead simple binary check. And it's a great reminder that sometimes the most elegant solution isn't about adding complexity, but about finding the right simple rule to follow. So the question I want to leave you with is this: what simple checks could solve the complex problems you're facing in your own work? Thanks for joining me.